All right, testing 1, 2, 3, testing 1, 2, 3. I've got motion on the bars there. We are live. Greetings, greetings, travelers. It's nice to be back. Here's hoping you and yours are doing well, wherever on the planet you happen to be. My name is Mike. Welcome to Earthshan Education. This is our YouTube / Twitch / Facebook outlet for astronomy. We have been on hiatus for a little while. Through no fault of our own. That was a video card. Actually, a fan on our video card failed, and me being a nice guy, I let somebody borrow my spare video card because they needed one, and with the global lack of video cards, it's been a while before, it took a while to get our video card back, so we're back. We're happy to be back. Hi, Elsie. We have a cat and a dog present for our presentation. Wonderful, wonderful news. Let's go ahead and get rid of this. Yes, we are on the wrong screen. Wonderful. Off to a good start. Fat beats, though. Welcome, welcome, welcome. This is our planetarium. It doesn't look like much right now, but we will be using this to find our way around the sky. We'll be switching back and forth between this and a couple of other pieces of software, one of which is called Sandbox Universe Sandbox. I always say it backwards. It's Universe Sandbox. So we'll be taking a look at that in just a little bit. And we'll also be using just a web browser to kind of fill in the gaps in our show. You'll also notice I call you Stardusters. If you are new to the channel, please be sure to like and subscribe. That sounds like it might be slightly too loud. Yeah. Please like and subscribe to the channel. We try to put some content up, and again, with a video card failure, it was kind of hard to do anything. But we will be doing stuff now that we have our video card back. As you see, we call you Stardusters. We've got 62 Stardusters right now. We'd like to make that 100, so if you could share the channel, get people following here on YouTube and Facebook and Twitch.tv, we would greatly appreciate that. Now, one of the things we do is use a web browser, so let's get out of this. Get out of this. We'll talk about this in a second. There we go. Talk about our web browser. Yeah. So, we like to start our shows off every time with a little bit of, well, kind of general news. And to start off, we're going to start off with this. This is Astronomy Picture of the Day. This is something that you yourself can look up at any point. Just type in Astronomy Picture of the Day into your favorite web browser, and you will probably either come up with the current photo, which is this one here, or maybe the list. And the list looks like this. This list goes back through 2015, but it actually goes all the way back to 1995 when images were much smaller, and the web page kind of reflects the fact that it is a very much older, very much Web 1.0 style page. But every day there is a photo that you can click on. So you click on the thing, and it'll show you a picture. If you don't know what it is, it'll tell you not only the name of the photo, it'll say who took it, whether it's a individual person, or whether it was a university or a certain observatory. And then there's a little explanation at the bottom here, which is really helpful. And then you've got other hot links, so you can go down the rabbit hole of finding many, many, many new and wondrous things in the universe by using Astronomy Picture of the Day. Oh, this one is from yesterday, it looks like. Yep, this is from yesterday. This is the Andromeda Galaxy in ultraviolet. Ultraviolet, of course, being a kind of light that our human eyes cannot see. But this is a beautiful spiral galaxy. We'll look at this, the Andromeda Galaxy, a little bit later in the show. Our own Milky Way galaxy looks something like this. Galaxies, of course, are collections of stars, gas, dust, and planets that are many, 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 many millions of light years apart. Or light years apart, and thousands of light years across. Andromeda's about 230,000 light years across. If you don't know what a light year is, you just click on it and it'll tell you. But a light year is the distance that light can travel in a year. In a vacuum, it's a very large distance. Let's not get too hung up on numbers and things like that right now. This is more of a general astronomy thing, just trying to get people interested and learning a little bit about the world around them and the universe in which we live. This is actually today's photo. It's called Framed by Trees, a Window into the Galaxy. So, photographer's name is right down there. You can click on it. This is actually a picture looking up from a forest, it seems. And it's in Australia, South Australia. Also good to kind of read the description. But you're looking up at the core, the heart of the Milky Way. Now, this happens to be the best time of the year to see the heart, the core of our galaxy. As we orbit around the sun at night, we look at different parts of the galaxy. During the winter months, we look out towards the edge of the galaxy. During the summer months, we happen to peer towards the heart of the galaxy. So it will look something like this. This is obviously a composite photo, but we're going to see something like this in just a little bit when we get back to the planetarium. So I just wanted to kind of introduce that. Also very obvious in this photo is the fact that there's many, many colors when you look at the sky. Now, you may not really realize that. When you look up, you might just think, oh, well, all the stars are just kind of white-colored dots in the sky, and that is not true. Stars vary in color. A very good way of looking at things is a blue star. You see some blue stars right here. They tend to be hotter and brighter than the things around them. Very, very obvious looking. Red stars, however, are colder. Now, obviously, a star is very hot for a human. But compared to other stars, a red star, or a yellowish, dimmish colored star. Dimmish? What did I just say? Let's try that again. Take two. All right, so reddish colored stars are going to be older and colder stars. They live a lot longer than the blue stars. And relative to other stars, red stars tend to be colder. Especially red, very dark red. Some of these are going to be orange colored, like this one right here. And this one over here. We'll look at some stars here in just a little bit. We'll also look at the life cycle of stars in a little while as well. There we go. Let's get out of that. So that's today's astronomy picture of the day. Very good primer for everything. Other things I'd like to introduce is this. This is heavensabove.com, heavens-above.com. You can create a login if you'd like. Again, this is a older website. You'll notice it is very much Web 1.0. Doesn't look like much, but it's got a lot of information. Once you put your location in, I happen to be in the beautiful city of Rio Rancho, New Mexico. Everything becomes relative to your position, so it'll show you where the International Space Station is. You can click to see various satellites. You can even see where the Hubble is in relation to where you happen to live. Lots of cool interactive sky charts that you can click on. Things like this. So this is the current sky right now outside. Of course, the sun is noted by this thing right here, so you can't really see any of this. And that's okay. We'll look at that in just a little bit. So remember this picture in your head. Take a snapshot. All right. So anyway, astronomy picture of the day. and heavens-above.com. Really cool things you can see here. You can actually see tonight is the 19th. The space station will fly over tonight, very briefly, where I happen to live. So that's pretty cool. Going northwest to north. Good to know. Now, let's switch back. There we go. Let's switch back to the planetarium. This is open source. This is a planetarium you yourself can download. It is called Stellarium. You can put this, relative to wherever you happen to live. Lots of really cool menus you can bring up. Lots of different sky fields you can bring up. We'll talk about that in a little bit. But this is the exact same picture we just looked at just seconds ago. You probably just don't realize it. Well, we've got the sun out. There is a way to turn the sun off. Where's my atmosphere button? Good thing we're live. There we go. The exact same sky we just saw on the other chart. But because of the sun, and the sun's light diffracting off the atmosphere, refracting through the different atoms in our atmosphere, we don't really get to see the nighttime sky during the day, obviously. Now we're going to put things in motion. You will also notice along the edges of our planetarium we do have some cardinal points. You'll notice the sun going from east to west. So west is over here on the right hand side of our screen. We're going to see sunset here in just a couple moments. And again, this is set to tonight. So we're going to pause it right here at sunset. This is the sky tonight at sunset. Of course, it depends on where you happen to live. If you've got buildings or hills or mountains in the way, you may or may not see this exact sky. Sun rises in the east, sets in the west. We're facing south in the planetarium, and then we've got north way back here behind us. So please be aware. I'm going to try to at least let us know when we're going. So here we're facing south. And we're going to start off by looking at the west. We're going to talk about some planets, and we're talking about some constellations, and some other deep sky objects that are going to be out. First thing you'll notice is right away, as the sun is setting, you're going to see a very, very, very bright white-colored object in the west. It will not be twinkling. Twinkle, twinkle, little star is not just a fun nursery rhyme. It is also true to science. Stars twinkle, planets. Planets don't twinkle in the sky. And so that bright object is actually the planet Venus. Now, Venus is sometimes called the morning star or the evening star, depending on where it is in the sky. The problem is, it's not a star, it's a planet. Very close to Venus, in a weird little triangle, you're going to see a very reddish colored object. Depending again on your horizon, you may or may not see the planet Mars. Mars does have a very distinct reddish colored hue to it, but because this is low to the horizon, you may or may not be able to see this. So do be aware of that. I believe that was the space station that just went flying by as well. So there we go. We got Mars low to the horizon. We got Venus much higher up, and nearby you have Regulus. Now Regulus is a bright bluish colored star. It is the bottom of a question mark, and that question mark you can kind of see above. Draw a line here. Draw a line up this way. Very faint backwards question mark. If we draw lines like this, now it'll probably make more sense. That's the head of Leo the lion, the bright blue star, supposed to be the heart. Triangle tail. Way back here, think of a sphinx, very similar in shape. There's your Leo the lion, in the sky. So Mars and Venus hanging out right near Leo. We're going to talk about some constellations that are called zodiac constellations as well. Leo is one of them. We have a line right now in the planetarium. This line follows the path of the sun, which happens to also follow the path of the moon and the planets. We call this the plane of the ecliptic. You can also call it the zodiac, as the zodiac band of constellations are on the same path. So you got Leo the lion over here. We've got Virgo the virgin, Libra the scales, Scorpius or Scorpio, Sagittarius the archer, Capricorn the goat fish. All of these different things. We'll see more as we go along. You've probably heard of some of them. You'll note there are 12 of them. There's actually 13 if you really want to be technical, and that 13th one is actually Ophiuchus. This guy up here with the snake wrapped around him. But there you go. There's 12 official zodiac constellations. There's 12 months of the calendar year. There's also 7 days of the week, and there are what are called 7 classical planets in the sky. Now, you have to understand where the word planet comes from. The word planet means wanderer or vagabond. In ancient Greek, planetus, I believe, is where that comes from. And you've got 5 actual planets, what we call planets today: Mercury, Venus, Mars, Jupiter, and Saturn. Those were all visible to ancient peoples. They also included the sun and the moon. So a total of 7 objects, so the 7 quote-unquote classical planets. You'll also note that there's 7 days of the week. Each day of the week is named after one of these objects. So sun, Sunday, moon, Monday. Tuesday is actually Mars. If you speak a Romance language, in Spanish, martes is Tuesday, Mars. Miércoles is Wednesday. And Mercury is what that one's for. Thursday is Jueves, Jupiter. Friday is Venus. Saturday, Saturn, Saturday. Yeah, all 7 of the quote-unquote classical planets are the 7 days of the week, and of course the constellations are the months of the year where you'll find the sun traveling through them. So it's all based around building an astronomical calendar. There we go. So tonight, right at sunset, you will see the planet the planet Mars and the planet Venus in the western horizon. If you turn around and look towards your east, you'll see some interesting objects as well. If you wait a little bit after sunset, you'll see 2 more planets. So tonight, without a telescope, you will see not 1, not 2, not 3, but a total of 4 planets in the sky. The next planet you will see is the planet Saturn, which is a bright golden colored object rising up over the eastern horizon. And then not too long after that, you will find the planet Jupiter. You'll notice Jupiter hanging out right down here. Jupiter, much like Venus, is kind of a bright white in color. It is very, very absurdly bright. So you'll see now Venus is gone from the sky. So is Mars. And Saturn and Jupiter are now in the western sky. So again, you'll see 4 planets without a telescope tonight. We'll talk about these planets up close and in detail in just a second. But we want to talk about the moon, because the moon is out right now. And will be out tonight and for the next few evenings. If you've been watching the sky, the moon has been getting brighter and brighter. The moon goes through what is called lunar phases. Right now, the moon will be sitting in the constellation Scorpius, or Scorpio. If you zoom forward a few days, let's see. There we go. You'll see the moon will actually track from west to east. So you never really want to use the moon for finding a way around the sky unless it's for one particular night. Because if I said, look near the moon and look just north of it, but I'm talking about tonight, I'm talking about somewhere over here. But on the 22nd, so in 3 days, it'll be over here, and you'd be looking in the completely wrong portion of the sky. So really want to make sure you know what day you're talking about, especially if you're using the moon as a marker. Let's reset to tonight. So Never really want to make the moon go backwards, but there we go anyway. So, the moon. Let's talk about the moon. What do you know about the moon? Well, it's our only companion in the sky. Orbits around our planet. This is a close-up of the moon in this software. We'll take a look at the moon and the solar system here in just a second. This is our companion. The moon, as it orbits around our planet, again, goes through phases. They do all have names. We'll look at that in just a second. Whenever the bright side is on the right side like this, we call it a waxing moon. Whenever the bright side's on the left side, you call it a waning moon. This is not a crescent, unfortunately. This is actually in between. It's not fully full. It's not a crescent, so what do you call it? It's got a weird name. It's called a gibbous. This is a waxing gibbous moon. Let me go to a different software package real fast. That's going the wrong direction. That is wonderful. Let's go to our browser, shall we? That's not our browser. That's not our browser. There it is. Still on the wrong page, but that's okay. We're in the right place. I like using this. I didn't make it. I just like using it because it's super helpful. It's got us, the human, on the surface of the planet. This is the Earth looking at the North Pole. This is the moon looking at the moon's North Pole, and somewhere way off in the distance to the left will be the sun. And so this shows the phases of the moon from above. Makes lots of sense when you look at it this way. When the moon is between the sun and the earth, you have what is called a new moon. All the light bounces off the backside, so we don't see it here on the earth. You call it a new moon. You call the first portions of the phases the waxing moon. You see the waxing crescent as we keep growing here. 1/4 of the way around our planet, you have a first quarter moon. Funny how that works. 1 week later, you'll get a full moon. Now, a full moon rises when the sun sets. It is completely opposite the sun in the sky. That's called opposition. More importantly, it's called a full moon. See a full moon in just a few evenings. So do go out and look at it. Hopefully you won't have clouds like I've had the last few full moons. So there's your full moon. The moon is exactly halfway around the Earth. And now things go in reverse. You go into waning phase, waning gibbous. The moon begins to rise later and later and later after sunset, to the point where you really don't see the moon till 2, 3 o'clock in the morning. The waning gibbous becomes a waning crescent after you pass third quarter or last quarter moon, which is right here, 3/4 of the way around our planet. And there we go again with the waning crescent. Entering into the last little bits of the moon itself here. To complete the cycle, this is now a new moon once again. Now, that took how long? Were you paying attention? Remember I said earlier that the calendar is based off of astronomical events. We've got 12 months in a year. We've got 12 zodiac constellations. We've got 7 planets, classical planets, quote-unquote. The Sun, the Moon, and Mercury, Venus, Mars, Jupiter, and Saturn, making the 7 days of the week. And they're all based along the cycle of the moon. A month, a lunar month, is slightly different from a calendar month. But nonetheless, they were all based on the same thing, which is the orbit of the moon around our planet. I'm going to go ahead and let it keep going here, just to show you once again the phases of the moon. We're going to look at this in a 3-dimensional space in just a second, so please bear with me. Again, if you are new to the channel, please follow, like, subscribe, whichever option you have on the outlet you are watching from. We are live streaming to Facebook, Twitch, and YouTube all at the same time. So whichever it is, like, follow, subscribe, ring the bell. You know how it goes. Tell your friends, we're trying to get more subscribers, or Stardusters as we call them. Excuse me. You'll note once again 25, 26 days, 27 days over here. I'm going to try to stop it a little bit short. You'll see that a lunar cycle is just slightly shorter than a full month on the calendar. There we go. Ever so slightly shorter, but it's still the same basis. This is also why you don't always have a new moon and a full moon to start a month out. There are sometimes months where you get 2 full moons. That's called a blue moon, that second one. Happens rarely, but it does happen. Okay. Let's go back to our planetarium. No, we're not going to do the planetarium. We're going to go here instead. Now, in the planetarium, I told you there was a plane of the ecliptic, which was the path the sun, the moon, and all the planets appear to travel from our point of view here on the Earth. Here we are, looking at the sun. Ball of heated plasma and gases right in the middle of our solar system. A little bit off the center, but it's okay. Our sun has a family around it of planets and asteroids and moons. The first 4 planets we call terrestrial, Earth-like planets. Terra meaning Earth-like. The terrestrial planets, or the inner solar system. Mercury, Venus, Earth, and Mars are those 4. Then you have this little kind of debris field out here we call the asteroid belt. There's lots of asteroids. Some of them are really small. Some of them were big enough to be noticed, and they have names. Notice me, senpai. Then we got Jupiter, Saturn, Uranus, and Neptune. These are the gas giants, the Jovian planets, Jupiter-like planets. Out past Neptune, you have the trans-Neptunian objects, which are Quaoar, Sedna, Pluto, what used to be a planet, but is no longer a planet. So out here, you've got very cold, very small, very distant objects. But here's the point. Here's the rub. The orbit of Neptune, the orbit of Jupiter, Saturn, Uranus. Look at all these orbits. They're all basically on a nice flattened out plane, aren't they? Imagine a pizza. The middle is the sun. As you go out from the center here, you're spreading out your pizza sauce. You're tracing the orbits of the planets. When you look at it from the side, your pizza is nice and flat. At least you hope your pizza's flat, right? It's kind of the same idea. This is centrifugal force in motion. Causing things to flatten out over time, if they are gaseous especially. Let's take a look at the rock-solid Mercury. This is the hardest, one of the hardest planets to get to. It's so close to the sun, so it's really hard to kind of pinpoint how to put a satellite in orbit around it. If you do get a satellite in orbit around it, it's got to contend with the extreme heat going from day to night here on this planet. Talking 154 degrees Celsius, which, well, if you're one of those people that doesn't like using Celsius, let's do the conversion. That's 300 degrees Fahrenheit, at least on the side facing the sun. The side facing away from the sun is going to be about the same temperature, but below. So very, very, very cold. Not fun. All right, let's jump to the next planet. Mercury goes around the sun every 88 days or so, so sometimes it's in the evening sky, sometimes it's in the morning sky. Same with this planet. Right now, it's in the evening sky. We talked about this. This is the evening star, quote-unquote. This is Venus. It's about the size of the Earth. It is kind of like our evil twin. It's a little bit smaller than the Earth, a little bit less gravity, incredibly hot. We're talking like 900 degrees Fahrenheit, day or night, because of the intense amount of heat trapped in by this atmosphere. It's a very thick carbon dioxide-rich atmosphere. Not a pleasant place to be. Has been visited by a couple of orbiters and a couple of landers, and all the landers just don't make it very far. They just kind of land and then melt within a few hours. Here we have our beautiful planet Earth. This is a picture of the Earth at night, or at least a simulation of the Earth at night. You can actually see if I put this in motion really slowly. There we go. This is the result of humans. Our lights at night, our cities light up. You can see individual cities if you really know your geography. The places you want to be where there is the best sky. You're going to be out here in the oceans, or in the Australian outback, or certain parts of the desert in the Sahara. We'll look at the Earth-Moon system in just a little bit. We're going to keep going here. Here we have Mars, the red planet. Does have a very distinct reddish color to it. You will note on the north and south pole there are ice caps on the planet Mars. They are made of dry ice, carbon dioxide ice. This is Valles Marineris, Mariner Valley, a huge crack along the surface. Likely formed when the planet Mars cooled off. It does not have plate tectonics the way we do here on the Earth. And so this is all just one solid surface. So if the planet cooled off rapidly, it likely cooled and then cracked open, kind of like a pie crust. It's about 8 kilometers deep, or 5 miles deep at its deepest point. If you were to put this on a map of the United States, New York would be on one side and San Francisco would be on the other. So this would cover the whole U.S. Really big, or probably, most of Europe if you want to look at it that way. Nearby, you've got the Tharsis Montes. These are the mountains of Tharsis. 3 shield volcanoes right here, and then Olympus Mons. This right here. This pimple on the planet Mars. Well, it is huge. It's about 650 kilometers from one side to the other. That's about 400 miles across. That would cover up the state of New Mexico, the state of Arizona, the state of Colorado, or the state of Utah. Pick one, it would cover up either one. And it reaches up about 40 kilometers, which is about 25 miles or so, above the surface. So it's a huge blemish along the surface, reaching up towards the space above the atmosphere. Very, very cool. Mars we've studied very, very often because, well, we're intrigued by it for whatever reason. It is a small, inhospitable world. It would not be easy to live on it, but it might be the best choice if we're going to have an outpost. After you live on the moon, you live on Mars. After you pass the asteroid belt, you find the gas giants. This is gas giant Jupiter. There are ways of getting... Let's see here. There are ways of adding in the rings around Jupiter, so let's add those in. There we go. So Jupiter does have rings. If you didn't know, now you know. They are made of very... There we go. They are made of very dim particles. They're made of chunks of asteroids that have been torn up over the years, so you don't really actually see the rings of Jupiter very well, if at all. Unless you're behind the planet. There we go. Now, there are moons around Jupiter. Jupiter has an immense... Look at all these little dots you see here. These are all in orbit around the planet Jupiter. Crazy to think of. That's a huge family. There are 4 large moons called the Galilean moons, if you want to call them that. They are Io, Europa, Ganymede, and Callisto. Io is a volcanic world. Well, its surface probably doesn't even look like this anymore. It's too close to Jupiter, so it's actually being pulled apart by the gravity of the planet and the gravity of the larger moon known as Ganymede. So it's really volcanic, chucking up different amounts of volcanic material onto its surface, into the area around it. Europa is an icy moon with cracks along its surface. This surface is completely solid. Most scientists believe that there's actually an ocean, likely a saltwater ocean, under the surface of Europa, which always, of course, then brings up the next question. If there's salt water, could there be life? It's a good question. Ganymede is the next moon out that we need to talk about. This is Ganymede, the largest moon in the solar system. If it wasn't orbiting around Jupiter, it would be a planet slightly bigger than Mercury. There it is. Got some impact craters on its icy surface. There might actually be ocean water under Ganymede surface as well. Finally, we have Callisto, another one of these larger ice moons. Look at how heavily impacted this moon is. These four moons that I have mentioned, Io, Europa, Ganymede, and Callisto, when you look at Jupiter through a telescope, you will actually see them, assuming they're on a side that you can see. Sometimes they go behind the planet. You can't actually see them through a telescope at that point. But if you are looking at Jupiter, there's a highly likely chance you'll see at least one or two of these moons next to the planet. It'd be very cool. You might also get to see this. This is the red spot, the Great Red Spot. It's been going on for at least 400 years, if not much, much longer. It was first noticed by Galileo Galilei back in 1608, 1609, somewhere in there. It's a huge storm. You could fit the Earth in it 3 or 4 times from left to right. Looks like a big eyeball. Kind of creepy, but really awesome to see. So this is the largest planet in the solar system. This is Jupiter, which again you can see tonight without a telescope. Let's see if we can turn off all the moons and stuff to save on memory, because it will kill things. Okay, fine. We'll do this the hard way. We'll just reload the whole simulation. I've just noticed that as soon as you start adding in the extra moons and extra rings and stuff, it really slows everything down. Not just because the computer, it's just it's got a lot of stuff to... It's got a lot of motion to add in. So here's Saturn, the next planet out, which, as you can see, doesn't have any rings on it at the moment. We need to add those in, so let's add in some moons, number 1. And then let's add in the rings of Saturn. There we go. Much better. Now, the rings of Saturn are made of ice and dust. Mostly ice. They reflect a huge amount of sunlight, and that's why we can actually see the rings from the planet Earth. Saturn does have some very strange features, including a weird octagonal shape at its north pole. Or is it a hexagon? I think it's a hexagon. There are many, many, many moons around the planet Saturn. The 2 that I want to highlight are Enceladus, which is right in here. Enceladus is very much like Europa. Europa, again, we just looked at with Jupiter. Enceladus has an icy crust. Under that crust, it is likely an ocean of salt water flowing around. In fact, there's actually geysers spewing water up from the surface of this little icy moon. In fact, speaking of water, if you haven't done so, you should probably hydrate yourself. Take a moment out right now to drink some water. Always stay hydrated, please. There we go. The next moon I wanted to talk about with Saturn is actually way out here. Pretty far away from the main planet body, isn't it? But it's this one. Titan. Titan is the only satellite or moon in our solar system with an atmosphere. Now, we have pierced this atmosphere with instruments on the Earth and instruments around our planet, but we have also sent a lander. The Cassini-Huygens mission, about a decade ago, if not a little bit longer. had an orbiter around Saturn, and it had a lander, the Huygens lander, which actually pierced the atmosphere, fell on through, parachuted down, took a bunch of photos, and then landed in what is likely a methane ocean, or a methane river. I forget exactly where it landed. But there's methane, liquid methane, or natural gas as we call it here, all throughout this atmosphere. It's just very, very cold. So there's a look at the Saturn system. Let's go over here to Uranus. Uranus looks like this. Now, Uranus does also have a family, not as impressive as Saturn and Jupiter's family, but it does have some moons, but you'll notice they're all on a very distinct plane. They all look vertical to us, don't they? They're going this way. Saturn and Jupiter, they were going this way. Well, that's the interesting thing about Uranus. Hey, wait a minute. Go back to Uranus. Hey, guys. There we go. With Uranus, you're looking at a planet that was kicked over onto its side. It literally, imagine a spinning top. And then kick it over. Uranus's rings, its moons, its satellites, they're all on their sides. No one has a clue why. Obviously something happened. Either there was a collision and it kicked the entire system over, or maybe something happened to pass by the sun, and that caused some sort of gravitational shift that far out in the solar system, and it caused Uranus to kick over. Uranus and its tilted over side take a very long time to go around the sun, but the weird thing is that this is the North Pole right here. This is the South Pole back here. So the North Pole faces the sun for half the year, then the South Pole faces the sun for half the year. It's very, very different from our orbit. Very, very different from how we rotate around our own axis. Where's Neptune? There you are. Last one we're going to talk about, Neptune. The blue one. Hence the name Neptune, named after the god of the sea. There are some moons around Neptune that are very interesting. They are, of course, very, very, very cold. Neptune does have a dark spot on its upper atmosphere. Again, these are gas giant planets. These are just big balls of gas, hydrogen, helium, methane, things like that. Doesn't seem that this simulation has it, but there's actually a dark spot. Looks like the Great Red Spot on Jupiter, but nope, it's on Neptune instead. This is Triton. This is actually a very strange moon. This is actually one orbiting around Neptune in the wrong direction. So if you imagine everybody's going clockwise, this one's going counterclockwise. Or if everybody's going counterclockwise, this one's going clockwise. It is orbiting the planet the wrong way. It is hypothetically an object that has been captured from further out. You see, Neptune happens to cross paths with Pluto and some other objects that are out here in what is called the Kuiper Belt, where all the comets and the cold objects live. Trying to find Pluto in this gigantic mess. There it is. You'll see Pluto's orbit is off-center. It's very much off-axis compared to everybody else. That's why Pluto is no longer a planet. There we go. This is a look at Pluto, and there are actually, I believe, there are 5 moons orbiting around Pluto. It's Pluto and Charon and Nix, and Styx, and Cerberus, and Hydra. There they all are. 1, 2, 3, 4. So this is a weird little, like, 5, 6 body, 1, 2, 3, 1, 2, 3, 6 body problem, so to speak. They all orbit around each other. Charon, or Sharon, I've heard it pronounced both ways, is tidally locked. It's kind of like our moon. It always has the same face, looking towards the main body, so in this case, Pluto. Very, very cool. Freezing out here, in fact. That's our solar system in a nutshell. And as we talked about a little bit ago, we're going to look at the Earth-Moon system. There we go. We looked at the phases a little bit already, but I just wanted to kind of show you. There's the Earth doing Earth things. There's the moon as it orbits around the planet. The dark splotches are seas, or mare, meaning sea. Ocean, I should say. Excuse me. We're going to put things in motion. It will look like the moon is orbiting, but it's actually just us kind of trailing along with it. The moon does rotate very, very slowly. It takes a full day, a full cycle on the moon is 29 Earth days, give or take. Or a full month, as we would call it. The backside, what people like to call the dark side of the moon, is not dark at all. It's just, we don't see that side. And of course, during what we call new moon phase, which is this phase right here, the backside of the moon gets all the sunlight, reflects it back towards the sun. This is the phase in which you can get the eclipses of the sun, which are, of course, not safe to look at without proper telescope filtration or filters over your eyes. From the Earth, however, this is what we would see. Let's see here. Let's rotate around. We're in 3D space. This is a little bit harder than you'd think. There we go. So, this is what new moon is, when the sun is between, the moon is between us and the sun, I should say. And as we continue to have the moon orbit around, you start to get crescent, so something like this. Start to get your waxing crescent. Can't lock the camera the way I'd like, and that's okay. We're just going to do this manually. Start to get the crescent moon becoming the gibbous moon. Gibbous moon gives us a full moon. Something like that. Yeah. That's a full moon. And then the cycle reverses. Lots of craters on the surface. Lots of heavy impacts. All of those could have been hitting us instead, but instead the moon took the brunt of that, so we gotta thank the moon for being a battering ram and taking the brunt of it all. Let's go back to our solar system. There we go. And back into the planetarium. So here we are again looking at the sky tonight. We have Mars, again, very low on the horizon. You may or may not see this depending on where you live. And depending on whether or not you have, you know, mountains or hills in the way, Mars will be really, really low, so I would not blame you if you don't get to see it. Venus, however, should be pretty easily seen. Venus goes through phases, believe it or not. We never see the full entire Venus, because if we did, it would be behind the sun, reflecting all the light back towards us. So you see crescent Venuses, or in this case a gibbous when it's furthest out. Even still, it will be very, very bright. As we said, you can follow a line across the sky from the two planets we've just talked about through a constellation called Virgo. And you'll see a bright blue star down here called Spica. I'll show you how to find that in just a second. We'll find the moon sitting in Scorpius, or Scorpio, once again, sitting right up here. Waxing gibbous, bright side on the right-hand side. Very close by, a bright reddish-colored star, the heart of Scorpius, or Scorpio. This is Antares, which literally means anti-Mars, or not Mars. Bright reddish-colored star right here. Just behind it, you will see a teapot-looking shape. That is Sagittarius, which is not only pointing its arrow towards the heart of the Scorpion, but towards the heart of the Milky Way, which is what we started out with at the beginning of the show, didn't we? Talking about this. We'll talk about the Milky Way galaxy in just a second, I promise. We're going to go across the sky again. This time we're going to wait for the planets to rise up. We are now looking east. And in the eastern part of the sky, you'll see two planets in the southeast. But rising up right at sunset, you will see a triangle of stars. These bright blue stars are easy to find, and they make what is called the Summer Triangle. Now, the Summer Triangle is not an actual constellation. It's what's called an asterism. It's just a grouping of stars that you can kind of use to find your way around, make different shapes. Possibly the most famous one is the Big Dipper. That's not a constellation, that's an asterism. But these three here are in 3 different constellations. The highest up one will be Vega. It is very, very bright. It's the brightest thing in this entire portion of the sky. Vega is in Lyra the Harp. Right up here. Just Lyra the Harp. Now, from Vega, you can draw a line. Where's my little drawing tool? There we go. Draw a line towards the horizon northeast, and you'll find another bright blue star. That is Deneb. Deneb is the tail of Cygnus the Swan. Draw a line between the two still. Stop in the middle and head towards the south. You'll find Altair. Vega, Deneb, and Altair make up your summer triangle. Let's try that again. They make up your summer triangle. Three different bright blue stars in 3 different constellations. Deneb is in Cygnus the Swan. Altair is in Aquila the Eagle. The Milky Way travels right through them. Just a few evenings back on the 7th, that's the Star Festival in Chinese and Japanese, and I believe even Vietnamese mythologies. And the Star Festival has to do with these 3 stars and the Milky Way going right in between them. If you want to know more about them, look them up. Star Festival. Now, going back towards the southeast sky. Time will advance. We've got Saturn. Again, Saturn's going to be in the sky for the next few months. Here's what it looks like tonight. So if you have a telescope, you will see the rings in this beautiful tilted fashion. Enceladus very close. Titan very far away. The ring system itself, there's a dark gap called the Cassini division. And depending on your telescope, maybe you'll see the Encke gap, which is this little thin gap way out here. There are moons actually in the ring system. We call them shepherd moons. They will shepherd the material of the rings around to make sure they don't collide with each other anymore. Back over to Jupiter. There we go. No red spot tonight, unfortunately. Io is not visible either, but you have Europa, Ganymede, and Callisto visible. It means Io is behind the planet. Now, let's do some constellation work, shall we? We're going to face north real fast. We're going to find the North Star. To do that, we need to find the Big Dipper, which I mentioned a little while ago. The Big Dipper is a good pointer to find your way around, but it is not a constellation. It is an asterism. The Big Dipper is part of Ursa Major, the Big Bear. There we go. In the sky. Now to find it, look for this particular shape. 3 stars making a tail, 4 stars making a cup. These are the 7 stars that make up the Big Dipper. 2 stars here, 2 stars here, 3 stars there. Now if you follow the arc of the Dipper's tail, you will arc to Arcturus, a bright yellowish colored star, in the constellation Boötes or Boötes. Right up here. Arc to Arcturus, and then spike to Spica. Spica is the brightest star in Virgo, which looks like a slug. Well, it's supposed to be a beautiful maiden in the sky. And that kind of gets you around the northwest to southwest portion of the sky when it comes to brighter stars. Coming back north, if you look at the Big Dipper, these two stars here, we call them the pointer stars, for they will point you to Polaris. Draw a line through them and keep drawing it. You'll end up right there. Polaris is the tail star of the Little Dipper, Ursa Minor, which again is weird. The Big Dipper is not a constellation, but the Little Dipper is. I don't make the rules. I just teach other people's rules, apparently. You're taking off? That's good. All right, well, have a wonderful afternoon. I'm just talking to chat. You don't see chat on screen, but I get to see chat myself. Thanks for stopping by. Again, tell your friends, like, subscribe, pass it around. Got 3 different outlets. Got YouTube, Facebook, and Twitch.tv. Please help us grow the channel. We appreciate that. The other thing we can find in this portion of the sky is going to be Cassiopeia, this beautiful queen who angered the gods and the nymphs by saying she was more prettier than the goddesses, and the beautiful sea nymphs, they got angry. They tied her up on her throne, threw her into the sky. You'll see here she is looking at herself in the mirror, quite vain indeed. There are 2 triangles that make her entire body here. You got an equilateral triangle and a obtuse, kind of squished out triangle. You can draw a line through the triangle itself. Yeah, complete the triangle like that. Turn this into an arrowhead. Boom. Polaris once again. So you can use either method. You can use the Big Dipper or you can use Cassiopeia. Knowing both is good because, well, Polaris, the pole star or the North Star, doesn't ever set unless you're really close to the horizon and close to the equator, I should say. Polaris should stay in the sky pretty much all the time. Depending on where you live, Polaris may be higher or lower in the sky. Right now, where I live, Polaris would be here. If I lived further north, like in Toronto, Canada, or in Alaska, the North Pole, the North Star, would be much higher up in the sky. If I lived in Mexico, or Miami, or Puerto Rico, somewhere close to the equator, the North Pole would be much lower to the sky, to the point where if you're right on the equator, the North Pole is either on the edge of the horizon, or just not visible whatsoever. But as you can see, the North Star pretty much stays in the same spot. It does wobble ever so slightly. This has not always been the North Star. Polaris is the current North Star. As we wobble around on our planet, sometimes the North Pole points towards other stars, kind of in between, in a little circle here. Thuban, this star right here in Draco the Dragon, this used to be pretty close to where the North Pole would point. That used to be considered the North Star. Things kind of wobbled away. There we go. Okay, so we've talked about planets. We talked about our solar system. Let's talk about kind of everything else. So, our star, the sun, is by itself, which is weird. Some stars are in what are called binary or trinary star systems, so there's 2 or 3 stars kind of orbiting around each other. Stars come in different sizes, of course. Let's make an empty star field here. We're just going to add some stars in, just to kind of show you the differences in stars. Here is our sun. Okay. Now, I said earlier that red stars tend to be smaller and redder, so let's put in a smaller red star. There's Wolf 359. Here's Proxima Centauri, which is the nearest star to us. Now, these are not their actual locations. I'm just kind of putting them in for comparing. Okay. See, the sun is bigger than these red dwarf stars, as they're called. The sun is also much brighter. What about other yellow stars? Well, here's Pollux. Pollux is a yellow star like our sun, but it's much bigger. What about blue stars? Let's try Vega. We talked about Vega. Look at that. That's a much brighter star, isn't it? It's bigger than the sun, but not as big as Pollux. So Pollux has something interesting going on. And here is Sirius. Seriously, it's really bright. It's the brightest star in the nighttime sky. It's also the name of my dog, who's sitting on my foot at the moment. My cat, also named after a star. She has vanished. Her name is Alcyone. There's Spica. As you can see, stars, again, the bright blue ones, they can be very large, too. So they can be hot, bright blue stars. But here's the thing. When stars approach the end of their lifetime, they puff up and become gigantic. Okay, I need to delete that. Let's try that again. Why can't I delete you? Ah! It didn't work. Fine. I'll make a new one. Alright, no shenanigans. This time we're just going to start putting stars and laying them out. There's the sun. There's Wolf 359. Proxima Centauri. There's Sirius. Here's much bigger star. That's Rigel. You can see the sun is very small compared to Rigel, but let's zoom out a little bit more. Let's put in Betelgeuse. Look at how small the sun is right here. This is the sun, which is bigger than these two stars, but smaller than that one. And as you can see, our sun is tiny compared to these very, very, very large stars. And even Betelgeuse is small compared to the largest of stars. So if you were to take Betelgeuse, or even this VY Canis Majoris, and put it here in the solar system of our sun, it would take up most of the solar system. Let's actually look at that, shall we? Let's remove the sun and replace it with one of these larger stars. Let's try with Betelgeuse, which is the armpit of Orion. Well, that ate up everything up to Jupiter, give or take. Let's try Antares, the heart of Scorpio. It's a little bit smaller, so that's right in the middle there. Let's try one of these bigger stars, shall we? Oh, look at that. It ate up everything almost out to Saturn. So just the star. Stars have life cycles. As stars get older, they will run out of what they are fusing in their core. Usually they're fusing hydrogen into helium, but as they get older, they will start fusing other elements on the periodic table. We can actually map stars out by looking at something like this. This is called the main sequence of stars, the HR diagram. You'll see there's lots of little red stars down here. Zoom in a little bit more so you can see the little dot representing the red long-living stars. Then you have what are called main sequence stars. All along this line, these are all kind of average stars. Our sun sitting right in here, right at 1. So right smack dab in the middle is where our sun is. Then you've got the brighter yellow and white, blue colored stars going this way. So as you go to the left, you get hotter. You also get brighter as you go up this direction. So luminosity, so the higher up you are up here, the brighter you are. Reflected in magnitude, you'll see spectral class and temperature related to color. So this chart has a lot of information on it. You have a horizontal branch called the subgiants coming off of here, the giants, and then the supergiants, the really huge stars that are up here. Some of them are trailing from here down this way. Some of them need to drop down this way. Some of them just go parallel that way. When they're supergiants, they will explode violently and become a white dwarf way down here. White dwarfs are the cores, the hot ember. Owie. Didn't mean to do that. It's kind of like when you barbecue something and you're left with hot coals left over. That's what's going on with a white dwarf. It's the hot coal left over after a star has died. It's not made of coal. Actually, likely made of diamonds. Hot carbon. That's kind of what's going on there with stars and their sizes. And this is kind of happening all over the place. Some stars, again, you have 2 or 3 of them getting very big and very old at the same time. Some stars, depending on how the system is set up, they might have one that gets really old and ready to explode, and the other one isn't. But this happens all over the place in what we call the Milky Way, which is what we see here. This is our galaxy. We happen to be around a star somewhere out along the edge of the Milky Way. So we believe our galaxy is a spiral galaxy. Some think it's a barred spiral, so there's a little bar going down the middle of it. There's different styles of galaxies. Some of them are like footballs, we call them elliptical galaxies. Some of them are spiral, like this. And some of them are irregular, which are kind of like a mashup of the two. Younger, brighter, hotter blue stars are going to be along the outside portions, as you can see there. Redder colored stars are going to be more towards the middle. You find the older stars around that spot right there in the middle. That is a black hole, supermassive black hole, an area of space so dense that not even light can escape it. And it's hanging out right smack dab in the middle of our galaxy, anchoring everything. But our galaxy is not alone. Our galaxy is one of many, many, many galaxies in what is called the local group of galaxies. It's not even the biggest one in the local group. There's the Milky Way right here. That's not the Milky Way. There's the Milky Way. Thank you. There's the Milky Way, looking slightly less of a spiral because of the way the rendering is, but you see there's a bunch of galaxies nearby that are in our orbit. And more importantly, there's a galaxy over there. That is the Andromeda Galaxy. The distance between our galaxy and the Andromeda Galaxy at the speed of light is 2.25 million light years, and shortening. Andromeda is actually getting closer to us. And at some point in the future, this galaxy will traverse all of this empty space, and our galaxy will traverse all of that empty space. They will merge, they will collide. So here we go, we have a little animation showing our galaxy merging into the Andromeda Galaxy. This, of course, is over many, many millions of years, but we have sped it up. So you see the galaxies begin to merge, this beautiful dance. The cores, the black holes, approaching each other, possibly merging, possibly missing each other, dancing around. You'll see all the stars kind of trying to find equilibrium around this black hole center right in here. What used to be spiral arms is now, well, multiple layers of arms. Some stars being chucked out into space, other stars merging into each other, exploding into supernovae. Very rare that'll happen, but sometimes stars can collide. There you go. That was a little bit about tonight, the night sky tonight for the next few evenings. It's also a little bit about the universe itself. Also a little bit about where we come from and where we're going. You see, when stars get older, they explode violently. We call them supernovae, or sometimes they don't always explode violently. Sometimes they die quietly. They leave behind a little cloud of gas and dust. We call them nebulae. They're all over the sky, if you know where to look. There's one that's actually pretty easy to find tonight. If you remember when we talked about the summer triangle. I'm just waiting for the sun to set here. There we go. Talk about the summer triangle. You're going to be looking over here. Got Vega, Deneb, and Altair. Remember that. Vega, Deneb, and Altair. Well, very close to Vega. Come on. Very close to Vega, in the constellation Lyra the Harp, you will find a star like our own that has died. This is something like the Sun. It is what is called the Ring Nebula now. It's a planetary nebula, round in shape like a planet. The outer layers kind of chucked out into space, and the white dwarf left behind in the middle there. Those layers have heavier elements. Most things start off with hydrogen, and then they get fused into helium, lithium, and carbon, nitrogen, oxygen, all the other things. All the way up to iron, and then after iron, things start getting a little wonky with stars. Stars start to die. But that's an important thing to realize, that iron is fused in the furnace of stars when stars explode, when stars get older. Iron is also in your blood. Our solar system is a second generation, or possibly third generation solar system. You and I are stardust. In our blood, we have iron. Hemoglobin reacts to oxygen, turns your blood red. Comes from stars. You're stardust. I'm stardust. We are stardust. Take care of yourselves. Go outside, look around. Hopefully this has kind of piqued your interest. We'll do other shows another day. We'll do Wednesday and Friday like we normally do. We'll talk about other things, maybe a little more in-depth if people want. Sometimes people just kind of pop in and sit and watch the show. Let me kind of lecture on, which is fine, but I'd much rather answer questions and show off specific things that you would like to see. Nonetheless, we hope you enjoyed the show. We did an hour and 20 minutes of astronomy content. You enjoyed them. Please share the channel if you can. And we will see you next time. Have a wonderful afternoon, evening, morning, wherever you happen to be.